Continue with our next lecture. Yeah, so like earlier we said, this yellow dot kind of filling into a straight line. And also that's a positive slope. So the taller parents do have taller children. This kind of the trend and distribution kind of meet what we thought. But how to really get to know the accuracy about the prediction? We can create our own prediction, but the most important thing, we want to check how is the accuracy about the prediction. So the next one, let's talk about prediction accuracy. We want to see how accurate our prediction is. So how to do that? So the first thing, of course, the prediction accuracy, we want to compare the predict value with the original data set value, right? So the differences between the real data set value and with the prediction value, we kind of know how is the error. If the error is big, of course, it's not good prediction. But the error kind of is we can handle that. We think that's a kind of reasonable range. Yeah, that prediction actually is, the accuracy is fine. So the first thing that's see here, right? So actually if we make the X is the prediction value, predicted value. So Y is the data value. So the difference is our error, right? So we have our prediction error. Of course, this function we need to apply on every child. So again, we have our heights, apply the function name. So this function, right, we have two arguments. So on the other hand, we need to pass two columns for that. So earlier we did add our prediction into one column. So we're using the prediction minus the child column so we can find the differences. Okay, so then we have the prediction error here. So this prediction error, of course, that will be a array, right? So if you want, you can display your array. Okay, but here we can just right away to add this prediction error, the array, into our heights table. So we add one more column we call arrows. So then we put our prediction arrows. On the first thing, don't forget, right, run our function definition. Okay, so we add the new arrow into our heights function, heights table. Yeah, so here is the number. Again, the number is not good enough, right? We do want to visualize that. Okay, so what kind of chart we should display the arrows? Now you want to see the arrow, how big it is, right? So that's the numerical number. We want to see the distribution, right? So that's the histogram. So histogram, we just make the arrow. Okay, we use according to the arrow, they will group that for us. Okay, so we see that's the arrow. So you can see the arrow here in the 0, that's kind of fix, meet your prediction. But to the right, that means you overestimate. To the left, that's you underestimate. So honestly, right, the bigger size, we are more accurate. But still, you see in the center, they are not very kind of the meet prediction, not as great as the other two bar. And also we can see the range, right? Even we say that's the positive value and the negative value, but they do have the error range actually between positive, I think this one even 10, to the negative 10. So do you accept that? Or maybe let's have more information. So this arrow, right, earlier actually we didn't include the sex about the child. So how about we see our prediction result? We have the histogram, right? So how about we group according to the different sex? Then we see how they are doing. So you can see here, we group in the yellow one is the male. Okay, so you see the yellow arrow. They kind of, toward to the left side, right? So left side is what? Negative. That's mean underestimate. So the female side actually a lot of overestimate. So what's that tell us? Pause the video. Yes, think about that. Then you can discuss with your classmates, your peer. So this actually tells us, because we use only the parents' average to apply on the children, we ignore the sex, the influence by the sex. So now results, the prediction result actually for the male child, we underestimate. The female child, we overestimate. So kind of, we better to separate our data, right? Okay, kind of makes sense, right? Right, so that's our discussion question according to our analysis about our prediction. So how could we take, we do see the sex actually kind of maybe have some arrow hiding in there. So we could take sex into account when we're making the prediction. So after we make the sex two group to make the new prediction, can we have smaller arrow? Let's see that. So according to the arrow we observed earlier, so maybe include the sex to predict the trial height. Maybe that's another good approach. So let's make another approach. We hope they will be smarter. So we just define as predict smarter function. So here we have two data input argument. The first one still is parent's height. So then how about we consider the sex as well? Okay, so remember before we have the height. According to the parent's height, we just want to get a 1 inch range, right? So we get the location. So now we are not only just take the sex only. How about we just make our sex? We're using the nearby, but we separate them. We separate them according to the input about the S. If the input is male, we only get male children. If that's the female, we only get female children. Then we find the average separately. Okay, so on the other hand, now we see after we have this new function, okay, so we apply for the parent's average height is 68. Then with the female children, okay, so then the average you see becomes 65. So how about the male children? Wow, the male children actually change, become 70. Instead of earlier we used the 68 for the children of parents' average height. The whole children average actually is above 68. They are 67 something. So kind of that's a better approach, right? So we do get better number to represent. But of course, we still need to see at the end, okay? So that's why here, since we know maybe they are better, so then let's have our height. Okay, so we change this one. We have the new prediction we call predict smarter, okay? So this one, this is the function, right? So we pass the predict smarter, we passing the parent's average height and the sex. So that's why we will get another average according to that. So that's the new predict height. Okay, so we call that smarter predict height. So this one actually is according to different sex, then the average will be different. So that's why here we add this column we call smarter prediction. So we passing the new predicted height, the new average according to the sex. So that's our new table. So one thing is afterward you will see the new table. Oh yeah, because we didn't display. Okay. So the new table. yeah, we have the smarter prediction. And also, we need to also find the arrow. So right, again, the arrow still is the difference function. Okay, so we pass in the children. That's the data, original data set height. So then we use the smarter prediction to compare with. Again, we add the new smarter arrow, okay, into the function, into the table. Again, yeah, in order to see that, we need to pass in, we need to display our function again. Okay. Yeah, so you kind of see, right, we do have smaller arrow if you compare these two columns. For each one, actually, if we say the absolute value, they do have smaller arrow, okay? But still, that's the histogram. So earlier we already showed you, right? If you have the smarter arrow, earlier, yeah, one thing that's the first one. If without the sex, we see how they look like. Now, even without the sex, you can see they are still smaller. The range, you see here, the range is smaller. And also you can see the zero kind of much higher than before. So again, let's add our group. Okay, so then you can see here is between 5 and 5. If we make that into the group, again, right, they are still in 5 and 5, but you can see, right, that's the, and also the arrow kind of overlap. They are not like quite different earlier. You see, earlier our male child, mostly the arrow we underestimate. Then we have a lot of overestimate for the female children. But now they kind of, yeah, that's the good range, right? Because they kind of, the normal distribution between the range is 5 and 5. So is this one is a smarter estimation? Yeah, smarter prediction. Yeah, sounds good. They are smarter prediction. I have almost 3 minutes left for this video. I want to really use the full 15 minutes. So here we already see we did have better prediction. So I want to use that 2 minutes to introduce more about the group function. So our group function, by default, you only give them the one argument. So that's the column you want to group. But one thing is, actually, we can do more, right? So by default, if you do the group method, they aggregate all the row with the same value for a column into a single row. So then that's in result in that table. We add that table, so we see we add one more column, right? So that column, according to the first argument, is which column you want to group by. Then the second column they create is according to the label you show. They just give you the frequency. So that's the default. The frequency, they will tell you the number of the group value. So if you don't specify the second argument, that's the default. But also you can specify your second argument. If you specify your second argument, you see, for example, you can give the extent to give you the total of that group, the value for all the elements. Or you can find other average or minimum value or something else. So then they can give you the list of all the group value. What does that mean? We see the example. We quickly see this example. Do you remember we have ice cream cone? So we have different flavor, right? So in this table, right, if we just start the group according to the flavor, so they right away give you this table according to the flavor, then they give you the count. So that means you have 1 bubble gum, you have 3 chocolate, you have 2 are strawberry. So right, if we add one more argument, for example, we want to find the price, we still want the price, but I want the average of the price. So that means just give them the numpy average. So they will according to the value they have here, so all the group, so then they find the average. Yeah, so that's the average from bubble gum. We only have 1, so then chocolate, you see the average from the 3 of them, the strawberry. Or if we want, how about we just find display the minimum for that group. So that's the group function. You can add more argument on that. They give you different output, but the default is the frequency.